Suppose we wanted to evaluate this integral, and suppose we wanted to do it by our method of direct substitution. First of all, you're going to have to go through these steps, which can look quite daunting, but as you practice more and more, the steps will start to flow better from one to the other, and it'll become second nature to you, but it does require lots of practice. Before we actually get started with this, let's copy the problem back down again. Step 1 is to set u equal to the expression raised to the power. So here we want to let u be equal to the expression 2x cubed plus 4x. And as I've said, if you're debating about what u should be, it's probably going to be the expression with the highest power of x. You've got this expression to the third power, which I chose. The alternative would be the 3x squared plus 2 with the power of 2. And since 3 is one higher than 2, you probably want to choose u to be the 2x cubed plus 4x. Step 2 says to compute du dx. That's the derivative of u with respect to x. That would be 6x squared plus 4. Step 3 is to solve for dx. So I will multiply both sides by dx. The dx is on the left, divide out. And that leaves you with du is equal to the expression 6x squared plus 4 times dx. Now remember, we're solving for dx, not du, so I need to divide both sides by that 6x squared plus 4, or equivalently multiply both sides by 1 over 6x squared plus 4. In either case, you'll notice that the 6x squared plus 4 divides out on the right, leaving just dx. So now we know that dx is the fraction 1 over the quantity 6x squared plus 4 multiplied by du. I also mentioned before that most of the time, if there's a common factor in the differential, you're probably going to want to factor it out. And I noticed that in that denominator, 6x squared plus 4, there's a common factor for 2. So I factor a 2 out of that. The denominator becomes 2 times the quantity 3x squared plus 2. I feel good about that choice when I look back in the integrand. Beside the factor beside the dx is in fact 3x squared plus 2. So that makes me feel that I made the right decision to factor out that 2. Most of the time you'll find that to be the case. Step 4 says if the integrand has a numeric, which is just a constant factor, you can move it outside the integral. That really doesn't apply here. You don't need to do that at all here. Step 5 says to substitute both the u and the expression represented by the dx into the integrand. So I'm going to take that u and put it in place of 2x cubed plus 4x. And if you'll notice, what that does is it turns it into u cubed. I'm not doing anything to the 3x squared plus 2, but I also want to replace the dx. And I notice that dx is that fraction 1 over the quantity 2 times 3x squared plus 2 du. So I plug that in place of dx. And when I do that, something nice happens that'll allow us to do step 6, which is to simplify the integrand. And what happened nice about this is that there's a 3x squared plus 2 that divides out of that integrand. And at this point, what you've done is remove all the x's from the integrand, which is what you want to do. Continuing to simplify it, you'll notice there's a 1/2 factor that can be moved out front. The 3x squared plus 2 is divided out. So all that's left is that 1/2 that you factored outside the integrand, the u to the third power, and all that's left to the right is that du. So what you've done in this simplification step is get rid of all the x's and dx's and leave the integrand with only u's and du's. Now that allows you, because by now you've gotten rid of all the x's, there are no x's, there are no dx's, that allows you to go to the general power rule and integrate it, because we've got the integral of u to the power. Also say at this point, don't forget the 1/2 that's out front. It's just sitting there right now, but it is still there. So go ahead and write that down, and then apply the general power rule for integration. The general power rule for integration says if we want to integrate u to a power, we integrate by increasing the power of u by 1 so that u to the third becomes u to the fourth, but we also multiply by 1 over that new power. So we do multiply by 1 over 4. And of course, every indefinite integral has a plus c. We can sort of wrap up the simplification now by multiplying a half times a fourth and getting an eighth. And now we're ready to do step 8, which is to substitute the x values back in. Remember that we put the u's in there. They weren't in there originally. So in the end, we have to put the x values back in. So I take that value, 2x cubed plus 4x, and put it back in place of the u, and that gives us the final answer. And keep in mind, if you have any doubt that you got the answer right, all you have to do is take the derivative of what I've just boxed in there and convince yourself when you take its derivative, you get what you started with. You can always check these integrals by differentiating and see if you get what you started with. So if you end up with that answer, differentiate it and see if you get back the integrand that you started with. If you do, you know you got your integral right. In any case, there's your answer.